Welcome back to the functions unit. Today we're going to be talking about slope-intercept form, so let's go ahead and take a look at that right now. Now when talking about slope, there are 4 different ways that we can describe slope. On a graph, we're going to take a look at that from going from left to right, just like when we read a book. So our first slope, when we're going from left to right, we can see that it's going up, so that is known as a positive slope. When we're looking at our next graph there, we can see if we're going from left to right, we see that our line is going down. So therefore, that slope is going to be known as negative slope. When we look at left to right, we see a slope that's just flat, that's not going one way up or down. That's known as no slope. And when we have lines going straight up and down, then we know that is undefined. We're not going to spend much time talking about undefined this year, but when we do have a vertical line like that, that is an undefined slope. Now let's go ahead and take a look at a few things to remember. So here we have a few important things to remember. When we're talking about slope, with that line going up or down, how much it's going up or down by is known as the steepness. So slope measures the steepness of the line. The y-intercept is where the line crosses the y-axis. So the y-axis is the axis that goes straight up and down. The y-intercept is where that line is going to cross that axis. And if we have both the slope and the y-intercept, we can graph a linear function. Although we've learned that we can plug things into our equations and then figure out what the x's and y's are that way to plot an equation, we can also plot our equation on a graph if we have only the slope and y-intercept. Let's see how that's done. Now let's take a look at the different parts of our linear function and how they're going to help us graph with the slope and y-intercept. So here we have a linear function in slope-intercept form. Slope-intercept form is written as y equals mx plus b. So now let's talk about what all those different variables stand for. So when we're talking about m stands for slope. So anytime that you see m in our equation, that's going to stand for slope. B is going to stand for our y-intercept. So anytime that we have a number on the end, that's going to be our y-intercept. So for example, if I had plus 3, then I would know my y-intercept is at 3. The other two numbers on there are the other two variables on there are variables we've talked about before. The y is going to be our output. So anytime that we're talking about that, it's going to be our output. And then our x is going to be our input. So again, x and y, things that we've talked about before. The new ones on here are the m for slope and the b for the y-intercept. Now let's see how this works on a graph. So here in example A, we've got two linear functions, y equals 2x minus 3 and y equals 1/4 x plus 3. We can graph both these linear equations without having our table and plugging things in, because we know where the slope is and we know where the y-intercept is. Remember, the slope is always going to be in front of the input, and the y-intercept is always going to be at the end, or our m in our b. So in our first linear function there, we have 2x minus 3. So we know that our y-intercept is going to be negative 3. So we're going to go down to 1, 2, 3, and put a point right there. And then our slope is going to be 2. So we know that our slope is going to be 2 over 1. So that means we're going to be rising 2 and running 1. So if I go up 1, 2 over 1, 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 and it works the same going down. So if I go down 2 and over 1, down 2 and over 1, down 2 and over 1. You can see now that as I've gone along, going up 2 over 1, I've created a line. So the last thing that I need to do is connect all of my dots using a line. Remember that I'm going to use a straight edge, and then I'm going to draw my lines all the way through the graph. Because remember, while these points are the points that we picked, they're not the only points that match this graph. So again, we need to have arrows on the end because it goes on forever and ever, as we can choose an infinite number of points. Now let's take a look at our next one. So we've got y equals 1/4 x plus 3. So we can tell a couple things from that. We can see that our y-intercept is going to be positive 3. So up 1, 2, 3, and put a dot. That's where we're going to start. Now our slope here is 1/4. So the good news is we don't have to try and figure out what the 2 over 1 is. It's going to tell us that we're going to have a rise of 1 and a run of 4. So a rise of 1 and a run of 4. So we're going to be going up 1 and over 4. So we're going to go up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4, up 1, and you can see that's off the graph, down 1, 1, 2, 3, 4, down 1, 1, 2, 3, 4, down 1, and you can see that's off the graph. So now that we have all of our points on our line there, we're going to go ahead and take our line tool again. And again, we're going to connect our dots because remember, while these are the points that we have, they're not the only points that match this graph. We're going to grab our line, we're going to drag it all the way through the graph, and we're going to use arrows to make sure that our graph is always going to be lined up and go on forever and ever. There we go. And we need our arrows. And we can see that we've plotted both of these without using our plug and chug method. We used our slope and our intercept. Now let's take a look at example B. So here in example B, it says using the table, create an equation in slope-intercept form. So this time we're going to make an equation given a table instead of making a graph given our equation. So we need to have a y equal statements for both of these tables. We need to figure out what our slope is going to be and what our y-intercept is going to be. So let's start with our y-intercept because that's a lot easier in our table. Remember, the y-intercept is going to be where it crosses the axis. So wherever x is 0, that's going to be our y-intercept. So here, our y-intercept is 0, negative 1. So we know the end of our equation is going to be minus 1. Now we need to come up with what our slope is. And remember, our slope is always going to be rise over run, or our x over our y. So if we're looking at our table over here, we can see that we're going to go plus 1, plus 1, plus 1, and plus 1. So we can see the run of our graph is going to be 1. So now we need to figure out what our rise is. So how much is it going up or down by? So this one we see that it's going up 4, up 4, up 4, and up 4. So our rise is going to be 4. So our first equation is y equals 4 over 1x minus 1, or you can simply write that as y equals 4x minus 1. Now looking at our next graph over there, the first thing we're going to do is find our y-intercept. That's where our x is going to be 0. So our y-intercept here is 7. So we know the end of our equation is going to be plus 7. Now we need to find our rise and our run. So start with our run. We can see that we've got a plus 3, plus 3, plus 3, and plus 3. So we know that our run is going to be 3. And then we need to do the same thing for our rise. So again, we're going to go plus 1, plus 1, plus 1, and plus 1, so that we can see that our rise is going to be 1. So I can see that my final equation here is y equals 1/3 x plus 7. So we're able to make our equation from a table. Now let's take a look at the last example. So here in example C, it says using the graphs below, identify the slope, the y-intercept, and write them as an equation in y equals mx plus b form. So again, we're going to be taking a look at things and we're going to be creating equations as y equals statements. So the first thing that we need to do is locate our slope and our intercept. Finding our intercept is easy. It's going to be where does it cross this y-axis. So for our first example, crossing the y-axis at positive 1, positive 2, we know the end of our equation is going to be plus 2. Now we need to find the slope. To find the slope, all we're going to do is count up and over until the graph finds a nice even place for us to count over and up to. So if I go up 1, over 1, not on the line, over 2, not on the line, over 3, not on the line, over 4, on the line. Let's check again. Up 1, not on the line, not on the line, not on the line, not on the line, over 4, on the line. So that we know if we go up 1 and over 4, we know that that is our slope. So 1/4 x, because we always need to put in our input. Now let's take a look at the second example there. Again, we're going to be looking for our y-intercept to start, which is the line down the middle. We can see it's going 1, 2. So we know it's down 2. So our intercept is negative 2. Now we need to notice that our slope here is going negative. As our line goes along, it's going down. In our first example, our line was going up, so we knew that our slope had to be positive. In this case, because the line is going down, our slope is going to be negative. And again, we're going to count to see where we can get on the line. So down 1, 2, 3, and over 1. So let's check that again. We're going down 1, 2, 3, and over 1. Let's check the same direction the other way. Up 1, 2, 3, and over 1. So that we know that our rise is going to be 3 and our run is going to be 1. So we know that our final equation is y equals negative 3x minus 2. That brings us to the end of this problem and this set of notes. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.